Hello everyone, welcome to the lecture 3. Um, in the previous lecture, we talked about the soils are multi-phase and particulate materials made of different phases like solid phase and liquid phase and the gas phase. And we also learned about the volume ratios, void ratio and porosity and degree of saturation. And also we talked about mass ratio, the water content. And several densities have been covered, the water density, solid density, and plus to that the specific gravity, and total density, dry density, and saturated density, and the submerged density. Today, we'll talk about the useful phase relations. So we're gonna derive several relations among the parameters. So the first relationship that we're going to drive is the relationship among the solid density and degree of saturation and void ratio and water content. So let me start with the water mass. And water mass will be the water density times water volume, right? From the density definition. And also from the water content, definition of the water content, water mass is water content times solid mass. And here also we can rewrite this one with rho s and v s. So let's define the first one as equation 1, and second one with equation 2. And if we combine equation 1 and equation 2, rho w v w is w rho s and vs, and we can move this vs into the left side, then onto the left side, and rho w and vw over vs equals rho s. And do you see that this one, right? This one is void ratio, right? Or, oh, sorry, it's not the void ratio, but we can rewrite this one by expanding it, VW over VV and VV over VS. So now we know that this is degree of saturation and this is void ratio. So we can finally come up with rho w s e is w rho s, right? And this is the equation 3. And we know that gs, the rho s over rho w is equal to gs. So we can simplify this equation into SE. Let me use the blue pen. SE is WGS. And this is very easy to remember. SE equals to WGS. And it's very convenient to use for the double checking of the recalculation later. If the soil is fully saturated, S will be 1. So then you have a simpler equation, removing the degree of saturation. Okay, that was the first expression, a first relation. And the second one is to find a relation among rho d and rho s and void ratio. So let me start with the total volume. And total volume is void volume plus solid volume, right? So then if we take out the solid volume, then 1 plus VV over VS. And here, as we did it before, this is the same with the void ratio. So VS is 1 plus E. Let's denote that this one is equation 4. So the total volume is equal to Vs times 1 plus E. So then bring up the dry density definition. Right here, then if we can replace the total volume with this equation 4, then ms over Vs times 1 plus E, then you find that this is the same with rho s. So the final equation will be rho s times 1 plus times 1 over 1 plus E. So this will be the one relation. Then you can remember well. Okay, so in the next page, there's a third one that we're gonna derive. Third relation is among the rho T, the total density, and dry density, rho D, and water content. This relation is used for the compaction in later in chapter 5 a lot, so it's really important. Rho T is mt over Vt, the total volume, and the total mass, right? And here the total mass is the ms, the solid mass plus the water mass. And if we can replace this one with, it's already says in here, right? So using the water content, we can remove the mw, the water mass, with the solid mass times water content. So then ms plus w ms over vt. So then we can take out the ms, and in the presence of it we have a 1 plus w left. And as you can note, this is the same with dry density, right? Solid density over total volume, solid mass over total volume. So then finally the total density is equal to rho d times 1 plus w, or you can express the dry density with the total density and the water content, rho t over 1 plus w. Okay, let's move on to the next one. The fourth one is among rho t and rho s and w and e. So this is simply just combining the this relation, rho d is rho s over 1 plus e, and this relation, you see why. Then the total density is ms over mt and 1 plus w. That's from here, right? Yeah, that's from here. And here from the equation 4, equation 4 was this one, the total volume as a function of Vs and void ratio. So the total volume is Vs 1 plus E. So then if you replace the total volume in this equation, then rho T, this becomes ms Vs. Right? And you can see that this one is the same with rho s, solid density. So the rho T is solid density and 1 plus W over 1 plus E. Or you can replace the solid density with the specific gravity. So rho W GS and 1 plus W over 1 plus E. Right? And the last one is getting the total density from solid density and water density and degree of saturation and void ratio. So let's recall the first relation. So first relation was what? SE equals GS and W, right? From here, you have this one. So then you can replace, express the water content with the rho S and rho W and S degree of saturation and void ratio, and substitute this W into the equation 5 in equation 5. Then equation 5 is the total density expressed as a function of rho S and W and E. Then this becomes the rho S times 1 plus rho W over rho S and S and E over 1 plus E. So then if you simplify, organize it, rho T is rho S plus rho W. So you're putting in N S E over 1 plus E. Or you can use the rho W and the GS to express the rho S. Then GS n plus SE over 1 plus E, so S times E and rho W. So this is typically used quite a lot when you compute the total density. And if the soil is fully saturated, then degree of saturation will be 100%, so this becomes 1. So then saturated density, the total density becomes saturated density. So the saturated density will be in this form. So comparing to this equation, this S becomes 1. So then it becomes this equation. So these relations that we derived, these 5 relations, the phase relations, are very good for quick calculation and the checking up the result. But I think I'm gonna say this one again. It's very important to use the phase diagram. So the rectangle with the air and water and the solid, and the left side you have volumes, and right side you have a mass, right? And by using that phase relation and phase diagram, you can compute the any parameters that we covered here. Okay, I'll see you later.